solve a lot of those problems. Um, displaying the build info. What you can barely see right there is it actually tells you the time and date when it was built. Again, this seems totally obvious, except for the fact that when you're not doing it, one of the big, evil, awful problems that can happen when you're making any sort of a web game is caching. Especially when you're close to release, subsequent versions of the game might not even look different, might have a particular hard-to-reproduce crash bug fixed. And it would stink if you play 2 games, reproduce the crash bug, and then realize you're just playing from your stale browser cache. So that helps you make sure that it is the very most recent version of the game. Saving the simulation results. This is actually very useful. You can see right there, the button actually says save aardvark. The technical term is aardvark. Somebody thought it was very cute to call it aardvark, so we do. And like I said before, that's just a huge XML file. Oftentimes, when you have a chaotic and complicated simulation, there's conditions the AI might not handle properly, and they might not show up very often. So that lets you save it to see exactly what was happening. You can also have debugging information in that result set. And the final thing, which really is critical for us, is the total memory. One thing that we really dislike about Unity is it's so hard to figure out where your memory is going. You could say the same thing about any managed memory environment. We have the same problem in Java on our servers. But when you're dealing with really large assets, like you are in any 3D game, not having really fine-grained memory control. We can't put a breakpoint on malloc. Not having that fine-grained memory control makes it really hard. When we first put this in, our game was taking about 2 gigabytes of memory, and Unity just allocates memory willy-nilly. Like there'll be times when you'll look at a field in a material, not even set anything, boom, it'll allocate 100K for some reason. So having that readout really helped us, and it also helps us when we ask QA. We think we've made some tweaks, or there's a new version of Firefox, or there's a new version of the Unity plugin. Let us know how the memory's doing. It makes it very easy for them to just jot it down every minute or so.
So what exactly does it display? The actual memory?
It's actually displaying how many bytes of memory it's using. So it could probably be a little more easy to read, but it's close enough.
What's a typical thing you do to fix memory problem?
Well, what we typically do, and this is completely disgusting, is we sprinkle our code with right here, the memory is this, right here, the memory is this, right here, the memory is this. Because you don't have a real debugger, again, we haven't played around with monodevelop in Unity 3. That's really the only way you can go about doing it. And we can kind of use this to say, oh, it happens when the touchdown notification comes up, or it happens when somebody gets tackled, or it happens when this particular commentator line occurs. But then somebody's really got to go in there and just sprinkle the code with all these debugging statements. It's painful, and it's a big waste of time, honestly. And another thing is kind of dimly make it out there better. We actually have a really complicated UI. Like you see these 3 different plays that are right here: the HB, ISO, the power toss, the decross. Well, each one of those is actually a panel with a lot of different buttons, so you can flip the direction of the player, you can click the heart because you hearted. And the only way to do that in Unity is to roll it yourself. And so every frame we're just creating and destroying so many objects. And the Unity just doesn't, or Mono just doesn't handle that very well. Anything else about memory before I move on? So debugging communication is size memory, the other really hard thing we have to work on. So there's a lot of components in the system. Obviously we've got a web page, or a web game, and the web page talks to the game server just to create a game. The web page has a game client on it, which is a whole separate entity. The game client obviously that talks to the game server. It also talks to the data service, so it can know all the statistics of your players. Both of these things, the client and the page, talk to the CDN. I don't know if anybody knows what a CDN is. It's Akamai or something. It's basically, we can serve all our static assets, all the pictures and stuff off our own data center. And if we wanted to, use our expensive bandwidth, or there are companies out there that are just, have edge servers all over the world. They've highly optimized the problem of getting the same data to everywhere on the planet. That's what a CDN is. So that's a lot of communication links. Oftentimes, when you're playing the game, all you know is your game hung. You're not even sure if it's hung. And it might have hung because the web page is trying to display an ad and it hasn't gotten it up yet. It might have hung because the game server is in a bad state. It might have hung because the game server crashed on a null pointer exception. How do you figure all this stuff out? He came up with something called the logger. So it's actually a separate application that runs on Macs and on PCs, and it displays everything that's happening in the game. Really important things it displays are the network messages going in and out. Oftentimes, the client guy will be talking to the server guy, and the client guy will be like, my client stopped. As soon as you send me the message to go into intermission, I'm going into intermission. You're in control. Server guy will be like, dude, of course I sent the message that we're going into intermission. This timer ran out. Why wouldn't I be sending it? The code is so simple. There's no way for it to break. So luckily, we have a record.
That's only turned on during development, right?
That's correct.
Or
and because
QA.
It's a separate application, it actually slows the game down significantly. But because it's a separate application, it's the kind of thing that there's a low risk of it going outside the walls of the company. And even if it did, it's just the way it's written. It's got keys in it that we could just roll out a new version and the old one wouldn't work. There's not much high value add information there. Like I said before, the only thing you can really do that we're aware of by hacking the game is get yourself more time in play calling. All of our e-commerce stuff, all our credit card numbers are stored by a separate vendor. So we're not handling credit cards or any of the transactions on our side.
Classic Heisenberg effect, where once you put, they went slower with this, and you don't see the tiny problems.
We actually have a huge problem with Flash where it appears that its TCP handler just throws out packets sometimes. You have no control over it. You don't know when it happens, and it happens below a layer you can get at with ActionScript. So yeah, sometimes one thing we noticed when we put this in it, and it started slowing down some of the network processing. That's actually how we found that bug. It also displays other things that are very that are very useful, such as when the client thinks it's changing states. Oftentimes there are timers on the client side, such as the game clock, and you want to know when the client actually thinks it's ending a quarter. You can save this whole log as just a text file, and it's really useful. You can email it to other people. It's very useful to give a developer when QA thinks they found a bug. They can be like, look, here's my log, and you can tell exactly what the client's thinking. A big challenge to getting this to making this useful is that everybody has to use it. It can't just be QA. It has to be our CEO when he plays. It has to be when our marketing guy plays with his son. They've got to use the logger. So, the problems that are hard to fix never happen when QA is sitting there looking at the game. It's just Murphy's Law. So everybody's got to use it all the time. So I want to talk a bit about workflow, because everybody loves merging scene files and all that fun stuff. So it's very important that non-programmers can author your game. Designers need to be able to iterate without having a program run the mix, and they need to be able to rapidly iterate. Artists need to be able to see their work in the actual environment with the actual lighting as a player would see it. All this sort of stuff is conventional wisdom in the game industry. It took a long time to get there, but it's the kind of thing where when you have a lot of non-game people, this is the kind of thing that this is metrics, but for the web people. You know, you want your designer to be able to redeploy a whole stack in under a minute. Yeah, absolutely. You have to be able to see their changes instantly. Obviously, the Unity editor makes a lot of this possible. You know, we're a sports game. We don't have to worry about spawn points, but there's still quite a lot of variables that we do need to tweak. So, the first thing, which has been really good for us, is the camera editor. Obviously, cameras are really huge in a sports game. When somebody throws a deep pass, you want the camera to zoom out enough so you can see how the field is developing. When a halfback runs it up the middle, you want to zoom in, but not so much that you can't see everybody on the line. So, the cool thing is, remember before I said we can save the results of the simulation? Well, we can also replay them in the Unity editor, and we can loop them. And this is actually kind of VCR style controls where we can actually slow it down so that the animators can look at how their animations look in slow-mo. And while we're doing all this in real time, a designer can be tweaking the camera values. And that's really cool because that lets them obviously iterate as rapidly as possible. Now, one thing which I hadn't known before was that one problem we had in development was as soon as you stop the game running, it gets rid of all the changes you made there, right? So somebody at Unite actually told me that there's something called player prefs, which you can use to serialize all the information there, so you can actually save it and then when the game stops running, keep their changes. So that's kind of cool. We haven't implemented that yet, though.
Quick question is, the camera editor is something that's part of Unity, is that correct?
No, so we
It's your
have
own
our
thing.
own. We have our own camera algorithms, different cameras, and there's just a lot of different values.
So this is your own editor that you built for your game, which is why you run on your RBAR files.
It runs on it is running in the Unity editor.
Right. You extend the Unity editor to do this, right?
It's more like a particular Unity project that uses the cameras that were in Unity and exposes all those values right there.
But the little VCR controls are running on your XML files.
Yes, we did this with the. This is actually just using the Unity GUI system.
Is what?
Using the Unity GUI system. We could put this in a web player if for some reason we wanted to.
Right, but you're running your simulation files.
Yes, that's right.
It's all C# code.
Yes.